So continuing on our lecture for section 4.4, evaluate the integral cosine theta by sine square theta d theta. So something like this, we don't have a quotient rule for taking antiderivative. So we need to figure out whether this can fit in any of our given formulae. Well, cosine theta over sine square theta, well, split the sine square theta as sine theta and a sine theta, yeah? So one of the sine theta goes under 1, the other under cosine. Well, cosine over sine theta is cotan, 1 over sine theta is cosecant. Integral of cosecant theta, cotan theta is negative cosecant theta. This comes from our table directly. All right. So you have your table. Make sure you have this handy. I had also given you the formulae for derivatives and antiderivatives. So that's what you need to use. All right. So the next example. Definite integral from 1 to 9 2t squared plus t squared root t minus 1. So first we need to find the antiderivative, okay? So keep the definite integral limits 1 to 9. You want to find antiderivative of this. Again, we don't have any quotient formula for antiderivatives. So we have to play with this. So division distributes. So t squared divides the t squared, gives you a 2 there. T squared cancels this t squares and you're left with square root t, which has been rewritten as t to the power half minus 1 over t squared is t to the negative 2. All right. Now you can take antiderivative. Antiderivative of 2, because it's simply a constant, you just need a t. So 2 gives me 2t. This, increase the power by 1 and divide by the new power. Likewise, this, increase the power by 1 and divide by the new power. All right. So now mind you, what is division by a fraction? It is multiplication by its reciprocal. Okay. So 2t plus 2/3 t to the power 3 halves plus, why did this become plus? Negative and a negative is a plus. T to the negative 1 goes downstairs, 1 over t. And the limits are now, notice once I finish taking the integral, the limits are no longer written here. They are written like this. 1 to 9, 1 to 9. What does this mean? Whatever I have, I will first evaluate 9 and subtract, evaluate 1. Okay. Now that is simply, you can use your calculator or whatnot. They have substituted 9 as it is and 1 as it is. Now these are not difficult to calculate, so let's do this by hand. 2 times 9 is 18. What is the meaning of 9 to the 3 halves? Well, take the square root, that's a 3, power 3, 27. So 2/3 times 27 is 18. This is plus 1/9. This is negative 2. This is negative 2/3. 1 to any power is 1, so it doesn't contribute. Lastly, negative 1. All right. So you have 18 plus 18 minus 2 minus 1, and then take care of the fractions. They have calculated it all to give us 32 and 4/9. All right. So this is a simple way of calculating definite integrals. Next, let's look at an application. Okay. Part 2 of the fundamental theorem says if f is continuous on closed interval ab, then integral a to b fx dx is capital F at the upper limit minus capital F at the lower limit, where capital F is any antiderivative. This means that capital F prime is little f, so the equation can be rewritten. Instead of little f, simply write capital F. prime, you see, because little f is capital F prime. So that's all, we have rewritten it. But this has an important understanding. Capital F prime represents what? It represents the rate of change of y equals fx. Derivative always represents the rate of change with respect to the independent variable. Whereas what is the meaning of capital FB minus capital FA? It is simply change in y when x changes from A to B. So derivative means rate of change, whereas FB minus FA is simply change in y. Note that y could, for instance, increase, then decrease, then increase again. Although y might change in both directions, FB minus FA represents the net change, overall change. Value at the right hand point minus value at the left hand point. What happens in between, it doesn't care. Value at the right hand point minus value at the left hand point. That's what FB minus FA is. Whereas derivative is the rate of change, how fast you change. Are you going positive or negative and so on. Okay. So we can reformulate the fundamental theorem of calculus part 2 in the words as follows. It's also called net change theorem. The integral of a rate of change, you see, the integral of the rate of change is the net change. Integral is net change. So integral of rate of change is net change. This principle can be applied to all the rates of change in natural and social sciences. Here are few examples. If Vt is the volume of water in a reservoir at time t, then its derivative is the rate at which water flows into the reservoir at time t. V is the volume, V prime t is the rate at which water flows in. So if we say T1 to T1 to T2 integral, V prime dt is Vt2 minus Vt1, what does that mean? Is the change of amount of water in the reservoir from time t1 and between time t1 and time t2. All right. So I'll continue next video.